Hi students, this is one of the extra sums from standard 9th which was from the old textbook. See what's given in this particular part. We have a segment AB in which C is the midpoint. They have given C is the midpoint of seg AB. Then from point A, perpendiculars are drawn. Point AD, line segment AD is perpendicular to line L and segment BE is perpendicular to line L. So information, C is the midpoint of seg AB, AD is perpendicular to line L and BE is perpendicular to line L. We are supposed to prove seg CD. Seg CD is congruent to seg DE. Got it? So to prove that is segment CD is congruent to segment CE. So there's a construction in this. Construction is we are supposed to draw a perpendicular from point C on line L. So it is CM perpendicular to line M. Now children, let's see how can we prove this particular sum. First point, we can write seg AD perpendicular to line L, seg BE perpendicular to line L. This is given. Seg CM is perpendicular to line L, but this is construction. Now just watch. There are three perpendiculars to same line L. There are three perpendiculars to same line L. Can you remember the corollary? Perpendiculars to the same line are parallel to each other. So what should I get? Therefore, seg AD is parallel to seg BE is parallel to seg CM. So what I get is that seg AD is parallel to seg CM parallel to seg BE. Reason for this is perpendiculars to same line L are parallel to each other. Now we have three lines which are parallel to each other. Now if I consider seg AB is a transversal. If seg AB is a transversal, so I get seg AC is congruent to seg CB because they have mentioned C is a midpoint. C midpoint given. So if my first transversal was AB, I got AC congruent to CB because C is the midpoint. Now I'll write if line L is a transversal. If I consider as line L as a transversal, in that case I should get seg DM is congruent to seg ME. So children, these are the three parallel lines. If first transversal makes congruent intercept, then second transversal will also make a congruent intercept. Therefore, I get this segment is congruent to this. So what I get is that segment DM is congruent to segment ME. So the reason for this is three parallel lines and intercept theorem. Okay, so I got some good information which I can use it further. So I'm putting it in box. So I got DM congruent to ME. Now let's enter inside a triangle. So I have not drawn that particular part because see my part is CD congruent to CE. So now I'm connecting CD with CM. Now if you watch, we have two triangles. In triangle CMD and triangle CME, you're able to pay attention here. देखो CMD and CME, these two triangles. Some informations are available. Thing is that these two are right angles because it's a perpendicular. Then we having this segment DM is congruent to ME. Then CM will be congruent to CM common segment. So I get seg CM is congruent to seg CM. This is common side. Next, angle CMD is congruent to angle CME. Reason for this, each 90 perpendicular construction, we have drawn perpendicular construction. Okay. Next, seg DM is congruent to seg EM. We have proved already here. Can you see? DM congruent to ME. So this is from statement number 3. So it was a segment, then an angle, then again a segment. So it is side, angle, side. Therefore, triangle CMD is congruent to triangle CME by SAS test of congruence. If these two triangles CMD and CMA are congruent, then I'll get hence seg CD will be congruent to seg CE. Seg CE, this is my corresponding sides of congruent triangles. This is how we prove CD is congruent to CE. CD is congruent to CE. For this, I have proved these two triangles congruent, correct? The triangles were triangle CMD congruent to triangle CME by SAS test, and due to which I got segment CD congruent to segment CE. Thank you.